Okay, tonight we have to talk about factoring quadratics. Now, you remember, we started by having a quadratic that looked like ax squared plus bx plus c. And we were writing this as a function, okay? And we were trying to graph it and do other things. But now we're going to start to get away from the graph for a minute. And we're just going to look at this piece, the expression, okay? And how else might we write it? Because the problem is, right now, this consists of three terms, okay? You have terms separated by addition or subtraction. So you have this first term, a second term, and a third term. But what's really helpful to us so many times is to have factors. So we prefer to have factors. Factors, as you remember, are things multiplied together. So if you had A times B, A and B are your factors. So what we're trying to do is change terms into factors, okay? So basically, this looks like the answer to a FOIL. Question, okay? You FOIL two things together and two binomials together and you get this. So let's start with factors just for one. So let's say I had x plus 3 times x minus 2, okay? These are two factors. So this is an example of two factors. Now, each one of these factors, this first factor and this second factor, is called a binomial. So each factor is a binomial because there are two terms in each side of those factors. But that's what we want, okay? So what happens, I want to remind you how to FOIL before we talk about how to unfoil something. So taking a roundabout way to do this, but trying to get some vocabulary. Let's go ahead and FOIL these or multiply these together. It's nothing more than a repeated distribution, okay? So if you're multiplying, and I'm going to draw these arrows one time, and I never want to see these arrows again. They are not, something that you want to be in the habit of doing. But to show you how I repeat the distribution, take x times this first term, and then I'm going to take x times the second term. Then I'll take the 3 times the first term and the 3 times the second term. So that's repeated distribution. So what happens is you get x squared, then x times the negative 2, then the 3 times the x, and then the 3 times the 2, negative 6. Why do we call this FOIL? Because if you look, this was the first terms. This one is the outer terms, where, let's see if I can find another color for you. The outer terms are these and these, and then we can have the inner terms, which are this one and this one, so inner. And finally, we have last terms, this one and this one. Okay, so FOIL, that's why we call it FOIL. So I'm pretty sure you guys know how to FOIL, and you're going to remember, of course, if I take that away, that you need to combine these two if they are like terms. And in this case they are, and they often will be, x squared plus x minus 6. So that's a reminder how to FOIL. Why don't you try this one? Try FOILing 2x plus 1 times x minus 3. Pause it, take a minute, and you should have gotten 2x squared minus 5x minus 3. Now, I don't need you to write this middle kind of line in the work. If you can go straight from here to here and do that work in your head, do mental math, that's terrific, and that'll greatly help your speed when you're taking these quizzes and tests. So try to add those two numbers together in your head. Alright, so that's FOIL, so now we're going to talk about factoring is unfoiling, okay? So how do we do this? This is something you've done a lot before, so I know you have. And we just need to practice again, okay? So let's try a couple problems. If I gave you x squared plus 14x plus 40, okay? This is just an expression. I can't solve it. I can't do anything else with it, but I can rewrite it so that it's factors instead of being in terms. So I'm going to factor this. And the way to do this is I look at this and I say, okay, this is a trinomial. It's probably going to be the product of two binomials, okay? So I'm going to start by writing those two parentheses. This is plus and plus, so these are going to be pluses as well. And how do you make an x squared? Well, you make that out of an x and an x. How do you make a 40? Okay, 40 has some choices, okay, of how to make that. So you want to think in your head all the different ways to make a 40. Well, there's 1 times 40, but 1 times 40 would make 40 here, but you have to add to 14 here. So those two numbers had to add up to 14 in the middle, and they have to times to 40 at the end. So 1 times 40 won't go together and make a 14 when you add, so that's not good. So then you can try 2 and 20, but those would add together to be a 22. That doesn't work. 3 doesn't work. 4 times 10. Oh, and lo and behold, when I add them, they would add to 14. So let me go 4 and 10. And that's my factor form right there. Okay? Let's try another one. Go ahead and you try this next one, x squared minus 11x plus 30. You'll start, if you remember, by writing down those parentheses. You have two parentheses. And you want to think about the signs. They multiply together to give a positive here, so the product is positive, but you have a negative here, so that means both of these have to be negative. Okay, and now I'll work on the terms and see what you get. We'll come back, pause it. Okay, I'm going to run through this one real quick. To get the x squared, you need x and x. To get a 30, I'm going to choose 5 and 6 that will multiply together to give 30, but they add together to give negative 11. So this is my factored form. Alright, let's start talking about some of the funny things that happen to make this a little harder. And one of the things that can happen is if that first term is negative, okay? And if that first term is negative, it's just awkward to deal with. So let's say you had something like this. Okay, the first thing you're going to want to do, rather than deal with this first negative sign, is factor it out. So you can always take out the negative sign from everything. So the negative comes out front, you need a parenthesis, and if you take a negative out, this becomes a minus 14x and minus 32. Okay, if you don't believe me, check it, go backwards, multiply that back in, and you'll see that it does work. So now I'm left to factor this. So I have a negative outside, and I have my two parentheses, and now I just have to think about how to make it come out. So a 32 when I multiply those two numbers together. Okay, well, 32 could be 4 and 8. 4 and 8 is the ones I thought of first for 32. But those numbers don't go together to give me 14. Ooh, that's a booger. What about 16 and 2? That would work. Pay attention to the signs. The negative here means one is a plus and one is a negative. Because this one is negative, that means the larger number should be the negative. So this is my larger number. So minus 16 and plus 2. And of course I need my x and x to make this x squared. So let's just double check. This makes 2x. And this makes minus 16x. If I combine these like terms, I have minus 14x, which is what I wanted right here. So this would be the factored form. Okay, let's see what else can happen. Okay, so interesting things also happen when a doesn't equal either a plus 1 or a negative 1. Okay, so a different little scenario here. Let's see if we can find an additional problem. Let's try this one. 2x squared plus 5x minus 12. And you look at this and say, okay, it's trinomial, 1, 2, 3. I'm going to start by making my 2 parentheses. Okay, this is a minus, so I know these have to have different signs, so one's a plus and one's a negative. But that's where I'm going to stop, because everything else that we've done before isn't quite the same. But it is really, so let's see what happens. So what's going on here? The first thing I'm going to think about is how to make a 2x squared. There's only one way to do it, really. You can split up the x's, okay, x and x, but one of them needs a 2, so that when you multiply these two things together, you get 2x squared, okay? Well, it's pretty much the only way we have to make a 2x squared. So that's definitely, I like that, it's going to stay. Okay. Now, I need to think about the next step, and that's going to be how to make the 12, okay? So how do I'm going to make the 12? Well, there are lots of choices for how to make a 12, okay? The first one that comes to mind is a 4 and 3, okay? So with this extra 2 here, I can't simply ask myself, can 4 and 3 go together to make the 5 in the middle? It's not that simple anymore. So what do? You just guess and test. So I'm going to try 4 and 3 and see what happens. I'm going to guess that it's 4 and 3, because that will make the 12, and I'm going to see what happens. This together makes a 4x, and the outer terms together make a negative 6x. Did those go together to give me 5x? No, so that didn't work. Alright, try something else. That didn't work. So this time, what you can do is you can switch the order. Maybe I put the 4 and the 3 in the wrong place. Okay, so let's put 3, then 4. See if that helps things, okay? So that gives me 3x. The other one gives me minus 8x. And together I get minus, oh great, minus 5x. So I have the 5, but I got the wrong plus and minus. So what does that mean? That means I have these in the wrong places. So let me go back, change this, make this one the minus, make this one the plus. So now this is minus 3x, this is plus 8x, that's plus 5x, and I'm happy as can be, and that's my answer. Because when I multiply those two things together by foiling, I get 2x squared plus 5x and minus 12, right? Which is what I was just trying to do. So A doesn't have to be a plus or minus 1. You just have to do a little bit more work. You just have to guess and test. All right, try and factor this one here with your 2 parentheses and guess and test on how to make that 26 so it all works out. Pause it if you want. Okay, and for this answer, I'm coming up with the 5x plus 13 and then the x plus 2. As you can see, when I was doing this, I didn't know the 5x pretty much had to go 5x and x. It's the only way to make a 5x squared, and the only way to make a 26 is a 26 and 1 or a 13 and 2. So I decided to start with 13 and 2, but I got it backwards, so that didn't work. So I tried it the other way. That one did work, so that one is my answer. Okay, so there's a little bit more that goes on. Okay, one of the things you're going to see me harp on over and over and over again is common factors first, okay? So a lot of times we try to factor things when we're missing a more obvious, okay, trying to make it harder. So remember, if there is a common factor, that can come out. So things like 2x squared minus 10x plus 8. Okay, that has a common factor. So you can take out a 2, right? It's common to every term. When you do that, you have to multiply by, this is kind of a remainder, okay? What's left behind when you take out a 2? Or it's actually dividing by 2. So what's left behind is an x squared in the first term, minus a 5x in the second term, and plus a 4 in the last term, okay? So now that you've got the common factor out, then look, I've got a much simpler trinomial to factor. So I could leave the 2 alone, it's just hanging out in the front, and start factoring this trinomial, x and x, 4 and 1, minus and minus. So look at that. That works out great, and I've now fully factored it because I remembered to take the common factor out first. Now you don't always get to do 2 things, right? Sometimes there's just a common factor. So let me make sure I do one of those examples. 3x squared minus 9x. That one does have a common factor, even though it's only 2 terms, like we've been doing so many of these with 3 terms. This has 2 terms, but you're always remembering looking for common factors first. There's a 3 in common to both of those terms. There's also an x in common to both of the terms. So when you take it out, times this remainder, okay, this first term is left with an x, and the second term is left with a 3. Okay, and you have to subtract it. So this would be the answer to how to factor that one. Okay, let's talk about what happens when you factor out pretty much everything in a term. So I want to make sure we get that done. Why don't you go ahead and try this problem. It's 25x squared plus 5x, and see if you can factor this. Pause it if you want. I'm going to go ahead. They both have a 5 in them, and they both have an x in them. So now I have my what's left behind, okay? In this first term, I have a 5 left behind and an x. Plus, right, I still need this plus. And then what is left behind in this second term? I took a 5x out of 5x, so the only thing left is a 1. 1 is the identity for multiplication and division. It's what's kind of lurking there and hiding. So the 1 is there. And you can convince yourself that that 1 needs to be there, because if you check yourself, you can go backwards. Let's distribute that back in and see if we get the right answer. 5x times 5x is 25x squared. 5x times 1 is plus 5x. So if you had forgotten this, you'd get it wrong. Okay, a special case is what we call the difference of squares. And it's not really special, but it's harder to recognize if you're not thinking about it. Where we had been doing, 3 terms get turned into 2 parentheses, 2 factors. This doesn't quite look exactly the same way. You might end up with something with x squared minus 36. And you say, that's only 2 terms. There is no common factor. Not so sure I could factor it anymore, but if there is a minus sign, and here's the real kicker for everybody, it has to be a difference. That means minus, okay, everybody? There has to be this minus sign right there. If that's true, then it is factorable, okay? So we will go ahead and it also has to be true that this is a perfect square and this is a perfect square, okay? So the x can be x and x, the 36 can be 6 and 6. Now, what do you do with the signs? Well, I want these 6 and 6 to multiply together to give me a negative. So 1's a plus and 1's a minus. And the reason this works is because this term gives me 6x, this term gives me minus 6x. What happens when I add my like terms together? I get 0x, which is just 0. So that's why there is no 0x showing here. Okay? So that's called a difference of squares. It has to be a minus sign between 2 perfect squares, and then you can factor it like we would a trinomial. Okay? So, and what's interesting about the trinomials is 1's a plus, 1's a minus, and these are called conjugates. That's another good word you might hear me use a lot. Okay? So I want to give you one to try, and then we better call it a day. Here's a problem for you to try and factor this one. Okay, so when you look at this, you said, yes, there is a minus between them. This is a perfect square, this is a perfect square. So it's a matter of 5x plus 2 and then 5x minus 2, and that would be your factored form. So we're going to do a lot of practice on this. Come prepared to do this all day long up at the board.